Hi everyone, I am Raghuram. I will be taking class on the chapter force from grade 10 ICSE physics textbook. Okay, from around 10 years of experience, 10 12 years of experience, what I realized is that students fail to understand the content or they fail to understand the topic due to only two reasons. One is ignorance in the classroom, or they are more interested in having fun in the classroom than listening to the class. Anyway, today we will directly enter into the topic. Okay, first topic is translational and rotational motion. All right, yeah. I'm very sure that from maybe from grade 6 onwards you have heard this word translatory motion of an object. Have you? Yeah. So here the word translatory indicates that the object moving as a whole object, which means it doesn't move part by part. If you can relate it to a train which is moving from one place to another, if the engine which is in the front of the train, that is the first part of the train, if it moves by a distance of 1 meter, each and every compartment of the train moves 1 meter at the same time. There is no time lag. In case of snake, if you compare the motion with the snake, the first half of the snake goes forward, leaving behind the second half. And then that first half of the snake pulls that remaining half of the snake. Okay, you observe the motion of that. Uh, Similarly, centipede, you would have seen a small worm like living being on this planet which has many legs, centipede. Hope you all know about it. Even this one also, it doesn't move as a single object. Instead, it moves part by part, right? Only first part moves first, leaving behind the remaining part of the body, right? So that cannot be considered as a translatory motion. Translatory motion means the whole object should move at the same time without having any time lag. Okay, that is first part is moving forward, second part is staying there itself. So that shouldn't happen. If that happens, then it cannot be called as translatory motion. Well, what is translatory motion now? Translatory motion is nothing but when a force is applied on an object, if it moves in the direction of force applied, expected is that it should move in the straight line. Okay, when the body is applied by a force and if that body moves in the straight line, it is called as translatory motion. Here they use the word called rigid body. What does rigid indicate here? The word rigid says which is strong, which is hard. Okay, it shouldn't be soft one, because the force applied on the body might be used to deform the shape of the object. You know, different effects of force. By now you must be knowing there are many effects of force. I don't want to talk about it, right? Force can change the shape of the object as well. So here, if the object is very soft, then it can, the force applied might not be used completely to move the object. Instead, a part of the force might be used to change the shape. That is why they use the word here called rigid body. So when the force is applied on a rigid body, if it moves as a whole from one place to another in the straight line, then we call it as translatory motion. Okay, well, next comes rotational motion. What is rotational motion? For example, if you look at the fan in our houses, most of the places, we use fans, right? Electric fan, what I'm talking about is, it is fixed at a point. When the electricity is supplied, it starts to rotate, right? So when an object is pivoted or fixed at a point, and if it revolves, if it rotates about a fixed axis, stationary axis, or if it spins about a fixed axis, we call it as rotatory motion or rotational motion. For example, in case of the doors, okay, you just open and close the door, So door is fixed at a point, you just open the door or you just close the door. It is, since it is fixed at a point, now it can be called as rotatory motion because the motion is about this axis. Got it? So if you take any book or if you place it here and you can just open and close it. So the rotation is about a particular axis, that is called rotational motion. Here body is fixed and it doesn't move from one place to another. Instead, it's keeping one axis, it just rotates about the axis, it just spins about the axis. Similarly, top, with which many kids play, right? So even the turning top, that's also one example when it is not moving from one place to another, when it is just rotating at a fixed point. Fan, electric fan is wonderful example where motors are used in so many cases, in mixie, grinder, fan, right? Wherever motors are used, so they are fixed at a point and they just rotate. Now comes moment of force or torque. Here, moment indicates turning effect of a force. You know what turning effect is? You are applying a force and that force causes the object to turn around. Only then we call it as moment of force or torque. Here, moment of force or torque indicates that force is applied on a body and it started to rotate or it started to turn around, keeping an axis fixed. Only then we can use this term called moment of force. Okay, there are so many examples about which we will be talking later in the second part. So here once I have drawn one small symbolic representation of fan. Don't think that it is exactly fan. Okay, it's not very good picture, but anyway, just to make you understand what it is. Suppose you are applying force here. Let's say you apply force here. As a result of that, this fan start to rotate, right? So how much force you apply, and from here to the point fixed point, here it is fixed, right? Fan is fixed here. So it is the point of application of force and this is the distance of the force. So from here to here is the distance. How much distance is there? Using that formula is made. Okay, that formula is moment of force is equal to force into perpendicular distance, right? So force means force is applied here, how much force you apply, and perpendicular distance is nothing but the distance between the direction of force applied and from here to here what distance is there. That's what we are talking about. So using this formula, now it's very easy for us to come to a conclusion. What are the factors affecting turning of a body or turning effect of a body? What is the formula? Force into perpendicular distance. So what are the factors? Force and the perpendicular distance are the factors affecting moment of force or torque of a body. Okay. Now if you are writing the SI unit, anyway, force is measured by, what is the SI unit of force? Newton. And what is the SI unit of distance? Meter. So Newton meter is the unit of moment of force. There are some examples there are some examples for this moment of force using this data, using this distance and force. What are the things we do in our life? What are the tools we use in our life to make our work easier? Okay, there are so many examples which we will discuss in the next video. Till then, take care. Bye bye.